Hi everybody, my name is Marius and today I'll be doing video 4 of a series of videos around ADVPN. As you can see, this is video 4 already, so I'm going to discuss full mesh versus partial mesh versus hub and spoke topologies, right, and how they basically set up. Throughout this video I'll be referring back to video 1, 2 and 3 as I go along. As a matter of fact, I'm actually starting with quite a configured infrastructure, alright, to save some time. Because this time I just want to focus on the full mesh, partial mesh and hub and spoke type environments. Right, so if I do refer back to the other videos, you're not quite sure what I'm talking about, please go back to the other videos, video 1, 2 and 3. Go through them and then you'll better understand, I'm sure. Okay, so without further ado, let's go forward. Effectively what we have is, right, we actually have an infrastructure that I've built already. And from that infrastructure point of view, you'll see this slide appear right now. This is the underlay network. Right, with a bit of an overlay background to it. So effectively, just very quickly to summarize, this has all been set up. Okay, all the IP addressing is working at the moment and so forth. And we've worked quite heavily, in different groups and so forth. And we've really set this all up with an overlay and an underlay network. Just to get everybody into or understand this, just one thing, I'm not going to be working on ISP 1 and 2 at all today. I'm not even going to go to them. Okay, we don't need them. They're part of the underlay network, service provider. They're not important. Right, not the service provider, but in this case. Right, so what we've done is, and we've maintained this throughout this video stream, right, is that we've got a group 1, a group 2, and a group 3. Sorry. So from a group 1 point of view, what we said was we're going to have intra and inter-area group communications. Why we have this is because of scalability. And to understand this better, you would want to watch video 3. Right, because they actually explain the scalability, how you can actually scale out. Now the nice thing about today's video is we actually move that forward a bit, alright, and you can actually see it integrates with video 3 and you'll start to understand how it becomes more scalable. Alright, so for this case, what I'm going to see right here is that I've got a group 1, I've got a group 2 and group 3, alright. Group 2 at the moment basically would have 2 connected spokes, and in group 3 we've got 1 connected spoke. At this point, whether it's full mesh or partial mesh doesn't really matter, or even a hub and spoke. It doesn't matter how you set up the groups. The cool thing about, of course, ADVPN phase 2 that we are now discussing in these videos is that I can actually have either hub and spoke environment, right? So effectively hub and spoke, right? And also to get across and down, or I could actually have a full mesh environment as well. And where these devices will set up a full mesh infrastructure through the VAM server. Okay, so that's quite important, and as we go forward, we'll discuss that. Very good. Right now, I'll start with the hub and spoke design. All right. With the hub and spoke, how do we know that's a hub and spoke design? Well, I'm going to focus on BGP for now. And the key here is, as a design de facto standard, what we'll say is if your hubs are all in the same group, right, or AS number, they are in the same group as well, group 1. But if they're same AS number 101, and your spokes are in unique groups or AS numbers 102 and 103. All right, this will basically would be a hub and spoke design. Very important. If we move into a partial mesh design, you'll see that something has changed. Right, suddenly now I've got AS 102 and AS 103. AS 101 has disappeared. Doesn't exist anymore. AS 101 used to be up here. All right, it used to be these guys here. But that's gone. What I've done is I've actually moved the actual hubs into the same AS as the spokes. As soon as we do that, we have a partial mesh or a full mesh environment with BGP. Okay, so that's the very quick, fast rule that we actually basically use. The reason for that, if you look at the previous slide, is what I have is I actually have an iBGP connection between these two devices. And we've got eBGP down there, all right, between the hub and spoke. And of course, if there's at some point also eBGP, if I wanted to set this up, but I'm not going to. Okay, if we move to this design, what I have is I actually have iBGP running in here and eBGP running between these two guys. The rules around iBGP and eBGP are different, they're not the same. Okay, so the inherent way that we set them up right, will determine, and it's easier to run this environment in a full mesh environment than with eBGP between the hub and spokes. You've already started seeing that in video 2 and 3, where I actually had to create allow AS, allow loop, so I could actually allow some of the traffic there, these guys, to be advertised to these guys there. Right, I had to come around and actually not break rules, but I had to add some commands to this hub here to allow that network to be advertised to an IBGP peer, right, on this side, through an eBGP connection. This time you'll see IBGP, it's a different story. Okay, brilliant. Full mesh, if you go from a partial mesh to a full mesh, nothing has changed. However, you'll see that the VAM server is encircled. The difference between full mesh and partial mesh will be determined by the VAM server. Right, so throughout this video you'll see I'll talk about intra area and inter area. Right, intra area is all determined, the mesh, right, partial, full mesh, hub and spoke, is pretty much all determined within a routing protocol, like BGP. Right, BGP. Right. On the other hand, the inter area connections, right, between areas, the difference would be determined on the VAM server. Right, the VAM server, we will decide whether this guy can set up a full mesh or not topology. The default behavior of the VAM server is there's no configuration, which means that the default behavior is to actually have a fully meshed environment here with BGP, a fully meshed environment over here with BGP, right, and this is also fully meshed. And then basically if spoke 2 wants to talk to spoke 3 or spoke 1 wants to talk to spoke 3, they have to go through a hub environment and across and down. That's the default behavior. By changing some of the behaviors on the VAM server, right, and what we're going to change basically is the shortcut. We're going to introduce a shortcut command for interesting traffic which points to an ACL. And in the ACL, we are going to basically say, well, ACL 3000 in this case, we'll basically use 3000. We're going to say we're going to have interesting traffic. So we're going to say if you come from a 21, 22 going to 31, or 31 going to 21, 22, this is great traffic. I want that to be fully meshed, and that'll be part of the ACL. And remember what happens then is that we don't push this shortcut information down to the spokes. That's not scalable. So what we do is we push that information. So we create a configuration on the VAM server. The VAM server will tell the hubs, hey, by the way guys, we have interesting traffic for shortcut. And in that shortcut he's going to take the lines that we've configured there and introduce them to the hub. This guy you'll see before we do a full mesh ping, right? Before he pings from this IP address 21 to 31, you'll see his routing table will have a BGP entry, BGP, right, to get to 31, I'm talking from spoke 1's point of view, via the tunnel 10.1.2.1. So the first packet will definitely fire to he doesn't know anything about this shortcut list or anything, this VAM server. Oh, sorry, this spoke. So he fires his first packet to his routing table. That's what it says. And as the packet goes there, of course it's routed, doesn't matter. But at the same time, the hub turns around and says, wait a moment, I've got an entry here for that access list, for this 21 going to 31. He then fires a packet back to the spoke saying, okay, in your case, you want to redirect to the VAM server. Okay, and basically what the VAM server does, he gives information back how to get there, and he says you can get there via 10.133. So he'll go and question the VAM server. Hey, by the way, VAM server, I want to get to 31.1. I know that it is 10.1.3.3. Can you please give me the public IP? The VAM server fires this information back to him. Right, he now knows the 3 things he needs to know. He knows the network, which is 192.168.31.0. He knows the private IP address, which is 10.1.3.3, and he knows the public IP, alright, which is 202. If I remember correctly, 115. I think it was 13.1 or something like that. Yep. So he knows how to get there, and he's got the 3 pieces of information. He then fires a packet directly across to this guy and says, hey, by the way, I want to set a position with you, and this is my information, private, public, and my network. and they then set up an ADVPN session between the two of them. Okay, so that's where this comes in. So the VAM server, when you want to do full mesh inter area, you have to configure it on the VAM server. If you want to do full mesh intra area, inside the area, you do it on the routing protocol. It's got nothing to do with the VAM server. And hopefully throughout this video I'll prove that to you. Okay, so right now what I'm going to do is I'm going to quickly jump over to our infrastructure that we've configured. And if you've seen the other videos, this should be quite familiar to you. Okay, that looks interesting. Yeah, I've done a reboot on all these devices, yeah. Okay, so what we do have is we've got hub 1 here and spoke 1, spoke 2, we've got spoke 3, and I've got hub 3 and the VAM server. So everything has been set up. I'm not going to go through all the configurations right now. Right, the one thing that will remain constant throughout would be the configuration of ADVPN and VAM client on hub 1, spoke 1, 2, 3 and hub 3. They're not going to change any configurations when it comes to VAM or ADVPN. Nothing. Not one single thing. Okay, the only thing that would change from an ADVPN VAM point of view would be at the final step when we go full mesh all over the place. I'm going to create that access list. As a matter of fact, I think it might already be there, I'm not sure. Right, but I'm going to create the access list if it's not there and apply it to the actual groups. Once I do that, you'll see that that information will be pushed to the actual hubs. Okay, the only thing I want to work with right now is I want to talk about the the BGP. And like we said with hub 1, the initial design, going back to my design, if you give me 1 second, I'll get there right now. There it is. What we want to do is in hub and spoke, we're going to have a BGP 101 in hub 1, and these spoke 1 and 2 will be in BGP 102. And effectively what we're going to do is we're just going to set up an actual peer statement. So my peering statement, I'm just going to change the color here. I'm going to create a peer that points there, and I'm going to have a peer that points there, and I'm going to say to him that anything coming from the 10.1.2.0/24 network, which is 3 and 4, is allowed to peer with me. Okay, that's the idea. There is no peer statements between spoke 1 and 2. That's not scalable. Okay, I don't want to do that ever. So because I only have one peer statement going up and one peer statement going up, right, effectively what will happen is he's going to say, well, the only way to get to 192.168.22.1, even though there's a logical connection there, right, I can get there via the public interfaces, it doesn't matter. He's going to always point it to his hub. And effectively what you'll see is all the traffic will always go according to the hubs themselves. Okay, for the 192.168.21, go to 22. That's what I'm going to show you right now. Okay, so let's get this back again. And sorry about that, that takes a while. Okay, there it is. Okay, so from a BGP point of view, so I think this is the easiest way to do it. BGP 101, we said is part of BGP 101. Display this. That's the easiest way to do this. Okay, so he's got a peer statement 10.1.1.3. Right, the 10.1.1.3 is hub 3. Display interface brief. Okay, there is 10.1.1.3 that I'm talking about. Okay, so he's got a peer statement to him that's in the same AS number. Remember 101. That 101 is BGP 101. So these are IBGP peers. Peer 10.1.2.0.24, which I said was 3, 4, whatever. I want to set up each and every one. You can, but I don't want to do that right now. Right? You would say that's AS number 102. So these guys, display interface brief, as I said before, is the 10.1.2.3, which is within this range there. 10.1.2.0. Okay, and his BGP would be BGP 102. BGP 102 and display this. Okay, so he's been set up for BGP 102. As I said, I'm not going to reset everything up from scratch. Okay, then I've got a peer statement, peer 10.1.1.3 enable. I have to enable the peers, and 10.1.2.0 enable. At the same time, I have to specify my network statements. Now this is something you have to be careful of. You're of course going to say 192.168.1.0, but at some point there's going to be a routing required. In full mesh especially, there's going to be routing required when I'm actually going to have an address of 10.1. I'm going to say to this guy, BGP spoke 1, for you to get to the 192.168.31 network, you can go via the 10.1.3. Now, if somebody is not advertising 10.1.3 at some point, right, and vice versa, 10.1.2 at some point, there's no routing in place. Remember, router routes based on routing protocols and routing tables. If there's no route, he will not fire the packet. Okay, so he needs to know the 10.1 network. He needs to know that overlay network as well. Okay, what I'm not doing, I don't have to advertise the 10.1 here because I'm not sending it downwards, downstream to somebody else. This is just one hop up. So to me, as long as I get the information of 10.1.2 and 10.1.1, and also if you look at this, BGP 101, sorry, that's going to be system. Display this. I also have a network statement for 10.1.3. So I now know how to get to 10.1.1, 10.1.2 and 10.1.3 for all the spokes. So later on, when I actually set up that static routes, which you'll see, to the 10.1.3 and the 10.1 whatever the case may be, then these guys know how to get there, out of which interfaces. Okay, quite important. Remember that. Okay, so that's the only funny thing that I've set up so far. Like I said before, peer 10.1.2.1, allow AS loop 1. If you don't do this, what will happen is this router here will not see router 2's or spoke 2's network interface, right, that 192 network. And the reason for that is very simple, is because eBGP, all right, hub, eBGP, these guys have an IBGP between spoke 1 and 2. So what he's saying is, why should I ever advertise your internal network between two IBGP peers? They should have a neighbor statement, but we know they don't have a neighbor statement. So in this case, what I'm allowing the hub to do from that command is I'm allowing the hub to send me at least one hop, one of the same AS number as me, how to get there. So he'll take his network, which is a 192.168.22.0, inside the same AS 102. I'm allowing him to send it to me once for the hub's point of view. Okay, and vice versa on spoke 2. So that's basically the setup. So if we do the following and we say BGP 102 and display this, I've got the same thing set up over there. I've got a peer statement, only one peer statement. There's no peer statement to my neighbor, right, which is 10.1.2.1. I'm not setting anything, sorry, 10.1.2.3. I'm not setting up between the two spokes because then it's not scalable anymore. Okay, so that's pretty much it. That's the setup done. So let's look at this. I'm going to do a couple of display commands to make sure everything is working. Then we know things are working well. Okay, so what's the first thing we need to do? We need to check the VAM server. VAM, display VAM server now. Display VAM server. Address map. Now I need to see at least 7 there. Because I've got 3 spokes and I've got 2 hubs in 2 areas each. So 2 hubs in 2 areas is 4 spokes, 4 hubs plus the 3 spokes, it's 7. So I see all 7 is in there. Another one, display VAM server private address. I need to see all 3 in there. Yep, all 3 is in there. So that's pretty good. Okay, I've got the 21, 22 and a 31. Okay, let's do a couple of things now just to do some interesting things here. So I'm going to say display ADVPN session. I've only got one session spoke and hub. I don't want to see a spoke to spoke session. This is hub and spoke environment. Yep. So if I do it this way, display IP routing table to get to 192.168.22.0. It's via my hub next hop address 10.1.2.1. And if I do the same thing for 31, it's still via the next hop hub. Right, now if I do a ping coming from a source of 192.168.21.1 going to 192.168.22.1, right, that's a perfect ping, no problem whatsoever. And if you do this, display ADVPN session, I still only have a spoke and hub session. I don't have a spoke to spoke session. So what I could also do is terminal monitor, terminal debug, and let's say display debug. Okay, VAM is on at the moment, so we can see when things start to fire. Okay, so at the moment, nothing's changing. If I even do a ping to 31, it should ping fine. and I don't see anything happening on the VAM server. The reason for that is it's all through the hub. There's no reason why the hub needs to tell the spoke to renegotiate any public or IP addressing through the VAM server, and the VAM server is completely out of this, which is phenomenal. Keep this in mind if you are building a very large network, right, with ADVPN. Think about it. Every time you set up a spoke-to-spoke ping in a hub and spoke environment, the VAM server is left alone. It's not connected to. Okay, so effectively that's a great place to start to look at from a scalability point of view. Once you go into a full mesh environment, every single spoke-to-spoke session setup will have to be negotiated through the VAM server. So obviously from a scalability point of view, be careful of that one, right? Because that will basically determine your scalability. That's just a hello packet. Okay, so keep that in mind as we move forward. So the idea right now is, as you can see, there's not much really happening here. It's a hub and spoke environment. It's a really simple setup. From a spoke point of view, the only thing that changes in BGP is that we've got a network statement which is unique in every single environment. We know we can automate that through an IMC type of deployment with a zero-touch deployment and so forth. Right, so that's why customers go for this. Hub and spoke, easy setup, not complicated at all, and it's straightforward. Right, so that just simplifies everything from that point of view. And you'll see when we get to the IPsec, it even simplifies it even further. As long as you understand the underlay network and the overlay network and how they integrate with each other. Good. Okay, so what I'm going to do now is, I've pretty much proven that we've got a hub and spoke environment. Right, there's not much more I can do here. So I'm going to say undo BGP 101. This is going to be fun. Okay, yes, there it is. BGP is dead. And I do the same thing over here. Undo BGP 102. Do we have to undo BGP 102? Let's quickly see. BGP. Yeah, we have to do that. Okay. It's the easiest way. BGP 102. Otherwise, I'm going to do a whole lot of undo commands and just confuse everybody. Let's do it this way. That's a better way to do it. Great. Undo BGP 102. Okay, and yes, sir, I do that as well. Nothing happens on the VAM server, remember? I said that before. For now, undo BGP 101. Yes, and undo BGP 103. Okay, so I've got no BGP running at the moment. Remember, this guy doesn't run BGP, my VAM server. He's running OSPF in the underlay network. Okay, so from his point of view, all the VAM is still working. Display, VAM, server, address map, everything there is still working. It's just BGP I'm changing, remember? Okay, this time what we want to do is we actually want to go across and actually build a partial mesh, which means I'm going to have a full mesh in each area. Remembering that hub will now be in the same area as the spokes. Okay, so let's start with that. Let's say BGP 102. This time it used to be 101, remember, before we started that. So this time it's 102. Right, and effectively what we're going to do now is we have to have two peer statements. I'm going to have a peer to my other hub and a peer for all my spokes. So let's start with that. Peer 10113. AS number this time is going to be 103. Previously it was 101. Remember, I'm moving them into the areas. That's different. Okay, I also have a peer 10.1.2.0.24. AS number 102. This time this is going to be IBGP because of the 103, right, versus the 102 versus the 101. I'm in both 102, 102. This means I'm on IBGP, and I'll have an eBGP to my peer in AS 103. Address family IPv4. Okay, then I say peer 10.1.1.3 enable and peer 10.1.2.0.24 enable. Yep. So now I have my two guys enabled. What I can do right now is, let's just set this up because we will see later on. Terminal monitor, terminal debug. Yep. That should also be interesting to see. Terminal monitor and terminal debug. Okay. BGP 102 and address family IPv4. Okay, we're back there again. Okay, so if I do a display this, I've just enabled my two peers. If I do a display BGP peer right now, what will happen? Well, there will be nothing. Okay, and the reason for that is because I haven't set up the other guys yet. Okay, good stuff. So what did I say about network statements? We want to still set up the network statements as we had before. Alright, so network 10.1.1.0 and I can do it this way, or I can say network 10.1.2.0.24 just to show you two different ways. And I also have a network 192.168.1.0.24 as well. So that's my three network statements. There is one command I am missing right now. I'm going to leave it like that. There's a reason I'm missing it out. There's one command. Okay, but I want to leave it for now. I wanted some things to fail, so that's the way we learn. It's not through success, but through failure. Okay, so spoke 1. Well, let's set up hub 3 quickly. That's easier. Then we have at least the two hubs talking to each other. So this is BGP 103, and I've got peer 10.1.1 and AS 102. That is the eBGP connection, and I also have peer 10.1.3.0.24 AS, and this is 103. That's iBGP, and I've got address family IPv4, and I've got peer 10.1.1 enable, and I've got peer 10.1.3.0.24 enable here, and then I've got my network statements, network 10.1.10.24, and I've got network 10.1.3.0.24, and I've got, if I remember correctly, 192.168. Sorry about that. Enable. Alright, 24. Okay, so that's pretty much established there. This guy's gone up on the other side. As you can see, they now have at least some type of communication going. Okay, so if you do a display this, nothing funny, nothing fancy. Like I said, there's one command missing. We'll sort it out just now. Okay, and that's effectively, do we have everything set up? 10.1.2, 10.1.3 there. Yeah, that's good. 192.168.10s. Yeah, 10.1.1.3, 10.1.1, 10.1.3.0, 10.1.2.0. Enable. I'm impressed. Life is easy, man. Okay, this is not very complicated so far. BGP 102, okay, which means I'm going to have an iBGP to the hub. Love it. Okay, so here, this actually gets quite easy now from a spoke point of view. I've got 10.1.2.1, AS number 102, and I've got no other peer, remember, only upwards to the hub. That's the idea about the scalability. IPv4, okay, and I've got peer 10.1.2.1 enable. Okay, the only other thing I still need to do is I basically have to specify my network 192.168.21.0.24. I can send this out. Okay, it'll be good to see and establish there just now, but in the meantime I'm going to go through to spoke 2, BGP 102, peer 10.1.2.1, AS 102. Oh, you see it's established. I love it. That's good. That's why I switch it on, because then I feel a bit better about this. Okay. Address family IPv4, okay, and peer 10.1.2.1 enable, and I have a network statement 192.168.22.0.24. Okay, so that's the only things I have to do there, and then I need to set up my BGP spoke 3, which is BGP 103, and I've got peer 10.1.3.1. AS number 103, if I remember correctly. Yeah, I think that was right. Address IPv4. Okay, that's a second established there. That's good. IPv4. Then I've got the enable, and I've got a network statement 192.168.31.0.24. Okay, that's my network statement. In principle, if I understand correctly, except for that one command, things should be almost working. Okay, I say almost. There's a very good reason I say almost. Okay, if you think about what's happened now is, and I'm going to prove it to you just now. What you don't want to do, if you're going to have, let's say, 1,000 odd spokes in an area, or let's say 500 spokes in an area, I cannot set up a neighbor statement on both ends. Alright, that says network 10.1.2.0.24. because I need to have at least one of the two parties in this TCP session to have a directed IP address. Otherwise, he doesn't know specifically how to connect to the other side. Okay, so if I set up a neighbor statement, I'm not going to go deep into BGP, but if I set up a neighbor state or peer statement here that says /24 and /24 on spoke 1 and 2, they would never connect to each other. I need a specific IP address to set up the TCP peer. It's not going to start pinging every single IP address in that range to try and set up a session. Okay, so I need to have a specific IP. We get away with it on the hub side because we have the spoke that has a specific IP, and I'm allowing the spoke to connect via a specific IP address, and because the BGP peer has a /24 inside that range, he will actually establish a session. So it's not scalable for me to set up 3,000 or 1,000 or 500 BGP peer statements. And what is also not scalable, when you add one more device, I have to go to 1,000 odd devices and add a peer statement back to the one extra spoke I've just added. Right, so that becomes very difficult to set up and maintain. So what we do is, the only way we can do it is to do a root reflection. But before I do it, I want to first of all prove to you what's happening right now. So if I did here, display IP routing table to get to 192.168.31.1, I go via the next hop of 10.1.1.3. Alright, remember that this is partial mesh because I haven't configured the VAM server. So that's pretty much what I want to do. Okay, if I do a display IP routing table, now watch this, 192.168.22.1, there's nothing. Okay, now this is where things, you have to keep your mind about this. Okay, what's happening is I've got 3 routers in the IBGP sessions. Okay, how should hub know that between spoke 1 and spoke 2 there is no session? Okay, so he's not going to forward traffic, right, based on the other spokes. He's not going to forward traffic between them unless he knows something about them. Okay, so the only way that BGP can work here is to actually root reflect. Okay, that is the rule that we have to do. Okay, so in BGP address family IPv4, right, this is going to take some time, please. It's not going to be quick, okay, because it's going to re-establish and renegotiate. Okay, so for peer 10.1 or 2.0 24, I want to reflect, write the client. That is a critical command. Okay, it's going to take some time, depending on timers and so forth. This will take some time to get through. Okay, it's going to get at the next update will basically come through with this information. So this will take some time to happen. So what we have to do this side is do the same thing. Okay, so address family, right now this will work because I only have one spoke in hub 3. Okay, so that works fine, no problem whatsoever. But what is important is that if I add a second spoke or a third spoke, it would stop working, it wouldn't work anymore. Okay, at least you couldn't have a full mesh inside the infrastructure. So address family, IPv4, peer 10.130.24, and we set reflect client. Okay, that's going to be important at some point. Now I have a next hop, which is 10.124. Look at that. Okay, what is 10.124? I want to do the difference between the two. 31, 10.133.113 is directly up, alright? So basically the next hop is the actual next hop of the router that's advertising it. And then that's through BGP. I've also got a 10.124, which is directly connected between the two spokes. So he now knows how to get to that spoke. But remember the one thing he doesn't have the spoke's public IP address yet. I'm talking about spoke 1 here. Spoke 1 does not have spoke 2 public IP address yet. He might know how to get there, but he doesn't know what it is. Okay, so this time, if I want a full mesh, if I do a display, ADVPN, session right now, there's nothing. If I ping this time, I just want to make sure this is running again. Terminal monitor and terminal debug. Okay, so I can see my VAM going on. This time, remember the previous time when I pinged from spoke to spoke, because it was hub and spoke, it had nothing to do with the VAM server. This time, ping -a, coming from 192.168.21.1, going to 192.168.22.1. Okay, this time there's a negotiation going on. That's what I spoke about, the redirect, right? Or not the redirect, but basically this negotiation. Because he's talking from one spoke to the other, and I want to set up a full mesh, I need a public IP address for him. And you'll see inside here that a public IP address was negotiated. There it is. Okay, so how do I get there? Even though I know the private or the overlay network address, I need to know the underlay network public address. Okay, if I do the display ADVPN session now I have a spoke to spoke session. However, at the very same time, what I'm going to do is I'm also going to ping 31 and see what happens. Well, nothing happens. If I do a session, I only have 2 sessions. Why? Because this is intra versus inter-area communication. Like I said, intra-area communication is controlled by the routing protocol. Inter-area communication full mesh is controlled by the VAM server. Okay, so what I have right now, if you think about it, I actually now have a partial mesh topology where one portion, area 2, right, or AS102, everybody in there can talk to each other directly, right, for a full mesh topology. But if I talk inter-area from one area to the other, I have to go through my hub. That's the only way I can get there. Okay, everybody's still happy with that? So if I do a display ADVPN session here, I should have 2 sessions as well, spoke to spoke. In this case, I'm only going to have 1 session. Display ADVPN session. I only have 1 session. Okay, because there's no other spokes inside group 3 that I can talk to. Okay, please not set up. Okay, so how do I turn this into a full mesh topology? For now, I'm going to do undo terminal monitor so I don't get bugged by this the whole time. Right, I'm just going to do some configuration. Display access controllers to all. Okay, I've got an access controller, so it's a undo ACL advanced 3000. Okay, I don't have it anymore. Display access controllers to all. I want to do it with you. Okay, so what we're going to do is we're going to go basically from a 192.168, 21.22 going to 31 or whatever 192s. So I'm going to create an access list to make it easier. Access control list, advanced 3000. Right. I'm going to say rule 10 permit IT coming from a source of 192.168.0.0.0.255.255 going to a destination of 192.168.0.0.0.255.255. So anything coming from 168.0.0 going to 192.168.0.0, which means anything going from 21.22 going to 31 or 31 vice versa, or any other place, other group that I might have that they want to talk to each other. This is going to be full mesh, yeah? But only the 192s. If anything else, it will be hub and spoke. So only for the 192.168 network will we actually have a full mesh environment. Happy? Okay. So now that I've done this, I now have to apply that to the groups. Right, remember that. So that was the VAM server ADVPN my domain. Okay. Oh, sorry, that's I did something wrong there. Domain. Okay, that's wrong. Okay. There it is. Okay, if I do a display as this, remember that was the VAM server that we set up right from the start. What I want to do is go to the groups, remember, and apply, if you remember video 3, I'm going to apply that access list as a shortcut list inside the groups. But before I do that, I'm going to go to the hub, right, and put and terminal to monitor and terminal debug and debug VAM client. Debug VAM client. Oh, right. What am I doing wrong? Maybe it'll help if I go all the way out. Debug VAM client. Oh, okay, and I do a display VAM client, right, shortcut list, interesting traffic. And right now, remember this from video 3, I have nothing. There's nothing that's interesting at the moment. There's no access controllers rules, right, in either the hub 1 group or the hub 1 backbone group. Okay, this is just a hello packet, just to show that again. Okay, so nothing's happening there. So let's go to hub group 2. The same thing, by the way, will happen on hub 3, but I'm not going to set it up right now all the way. I've set hub 1. Okay, so then I'm going to go to hub group 2, display this, and of course what we're going to do is we're going to say shortcut, interesting traffic, access control list, 3000. Immediately it negotiates with the other side. Now I've got the interesting traffic here. Okay, so that is quite interesting for us to see. So I wanted to show you something else. So remember that by default an access list has a permit any in HP. Okay, so the one thing I'm going to do is I'm going to go to access control list advanced 3000 just to make sure. Rule 100 deny IP. I wanted to show you this. Okay, so immediately what happens now, interesting, is there's a second rule that denies everything else. Okay, you can see that deny and a permit. So for a permit statement, that'll be full mesh. For a deny statement, that'll be hub and spoke. Okay, and the same thing should be sitting over here. Display ADVPN shortcut interesting traffic. Display VAM client shortcut. That might help. Interesting traffic. Okay, why is it not sitting here at the moment? Because I need to first go and apply it to the group, remember? So VAM server ADVPN my domain, this time we'll get it right, and hub group 3, and I say shortcut interesting traffic access control list. This time it's done, and let's see it this time. It's there. Now what I've done is I'm saying that anything going from 192.168 network going to 192.168 network is permitted, right, for full mesh. So this time let's do the thing again. Okay, so same thing, let's just do an ADVPN session. This time I still have the 2 sessions going, so there goes the ping this time. Alright, and let's see our sessions. Now I have 3 sessions, spoke to spoke, directly set up. Okay, and that's pretty much what I wanted to show you. But remember that if you do go for a full mesh environment, and this makes a lot of sense in a lot of places, it just sounds really exciting, that there is a definite impact on the VAM server. Okay, I don't have the debug running at the moment, but every time you're going to do a ping, let me show that to you. Okay, and terminal monitor. Okay, so, and terminal debug, let's make sure that's working. So if I quit, and I say reset ADVPN session, okay, and I do a ping, there it is. Okay, because it's now setting up a spoke again. Okay, so every time you're going to have a session set up or tear down, you're going to have some communication going to the VAM server. Just keep that in mind. The good thing is that it only happens once, okay, because the session's already been set up. Until the session times out, remember there's default timer, times out, and it needs to connect again, it will then set up a session again. So keep that in mind as you move forward. Okay, that brings me to the end of, and by the way guys, I didn't go very deep into the protocols themselves, because that's something I accept that you know already something about. Okay, so how BGP works, I just wanted to touch on a couple of commands that actually does make a big difference, right, that you have to keep your mind around. So there's enough information here to set up BGP. Of course, from an OSPF point of view, I'm not going to configure it. That's something that you have to figure out. Okay, but from an OSPF, if you want to go hub and spoke, you use the point to multi-point command on the interface tunnel. Right, if you go into a full mesh environment, remember that's intra area, not inter area, intra area. You go to a broadcast, OSPF broadcast configuration on the tunnel interfaces, and that'll change from hub and spoke to full mesh. Okay, I hope you enjoyed this video, and look forward to the next video where we'll discuss a little bit around adding more hubs and VAMs, right, from a scalability point of view. Thank you very much. Have a nice day.